Hello everyone, welcome back to my channel Study With Me. Today I'm going to explain about Chemistry Higher Level Paper 2, May 2021, Time Zone 2. If you find this video is helpful, please don't forget to subscribe and let your other friend knows about my channel to support me, and let's get started. Limestone can be converted into a variety of useful commercial products through the lime cycle. Limestone contains high percentage of calcium carbonate CaCO3. So these are the cycle. So calcium carbonate is heated to produce calcium oxide CaO. This is the reaction. CaCO3 solid decomposed to be CaO solid and CO2 gas. Calculate the volume of carbon dioxide produced at STP when 555 gram of calcium carbonate decompose. To find that, first we need to find the mole of calcium carbonate, which is 555 gram mass over molar mass, which is 5.55 mole. So if we find mole of CaCO3, you definitely will find the mole of CO2 because it has the same coefficient, so the number of mole will be the same as well. So to calculate volume of CO2, that would be N times Vm. So 5.55 times 22.7, then you will get 126 decimeter cube. Thermodynamic data for the decomposition of calcium carbonate is given: CaCO3, CaO, and CO2. So the product will be CaO and CO2, and this is the reactant. So calculate the enthalpy change reaction delta H in kilojoule for the decomposition of calcium carbonate. So that would be delta H product minus delta H reactant. So negative 635 plus negative 393.5 minus negative 1207, and you will get plus 179 kilojoule. Calculate the change in entropy delta S in J per K for the decomposition of calcium. The data also is given here. So delta S will be delta S product minus delta S reactant. So you can refer later to this data. So product will be 40 plus 214 minus 93, then you will get 161 J per Kelvin. Determine the temperature in Kelvin at which decomposition of calcium carbonate becomes spontaneous using B1, B2, and section 1 of the data booklet. So delta H, as we calculate on the previous question, it's plus 179 kilojoule, and for delta S is 161 joule per Kelvin, so that would be 0.161 kilojoule per Kelvin. Okay, so for delta G, the equation is delta H minus T delta S. So become spontaneous, delta G should be negative, so it should be smaller than 0, so that would be spontaneous. This means delta H smaller than T delta S. Okay, so then T equal to delta H divided by delta S, which is 179 divided by 0.161. Then you will get 1112 Kelvin. Okay, for just your information, if delta G positive, Okay, I will just make it down here because this is not the answer. If it's delta G positive at low temperature, so delta H should be positive and delta S also positive. So delta G will be non-spontaneous at low temperature. But for high temperature, if delta H positive and delta S positive, delta G will be negative, so it will be spontaneous. Sketch an energy profile for decomposition of calcium carbonate based on your answer 2B1. Labeling the axis and activation energy, EA. From the previous question, we got enthalpy plus 197 kilojoule. So that is endothermic. Endothermic reactant will start from here. And this is the curve. And you will get the product will be right here. So this is product and this is reactant. And this would be activation energy. And this would be potential energy. And this progress of reaction. State how adding a catalyst to the reaction would impact the enthalpy change of reaction, delta H, and the activation energy. Okay, so if we draw the curve, this would be the same, the one above here. So this would be the one with this would be activation energy. So when you add the catalyst, it will be slightly down here. So this will be with catalyst. Okay, but for delta H, which is right here, you add catalyst or without catalyst, delta H won't change. Therefore, for delta H, when you add catalyst, it will stay the same. But for activation energy, it will decreases. Because catalyst increases reaction rate by providing an alternative reaction pathway with a lower activation energy, but will not give any effect on delta H. The second step of the Lime cycle produced calcium hydroxide CaOH2. Write the equation for the reaction of CaOH2 aqueous with hydrochloric acid. CaOH2 aqueous with HCl aqueous. If you find difficulties to produce the product, you can dissociate them. So this OH minus and this one Ca2 plus, because this belong to Ca, and we get H plus and Cl minus. So Ca2 plus will pair with Cl minus. So Ca2 plus Cl minus. So crisscross, you will get CaCl2 aqueous and H2O, because OH and H plus, OH minus and H plus, which is liquid, and balance them. Determine the volume in decimeter cube of 0.015 molar calcium hydroxide solution needed to neutralize 35 centimeter cube of 0.025 molar HCl. From this, we can get mole of HCl, which is C times V, 0.035 decimeter cube times 0.025 mole per decimeter cube. You will get 0.00088 mole. Then when we look at the equation here. For CaOH, the coefficient is 1. HCl is 2. Therefore, 1/2 to calculate mole of CaOH2. So N CaOH2 will be half of mole of HCl, which is 0.00044 mole. So volume NaOH would be mole divided by concentration. So we've got the mole, we've got the concentration, which is 0.029 decimeter cube. Saturated calcium hydroxide solution is used to test for carbon dioxide. Calculate the pH of a 2.33 times 10 to the power negative 2 molar solution of calcium hydroxide, a strong base. Okay, so when we know the concentration of CaOH2, so CaOH2, it has 2 OH minus. Therefore, the concentration of OH minus, it's 2 times 2.33 times 10 to the power negative 2, which is 4.66 times 10 to the power negative 2. So be careful. So to find the question is calculate the pH. So we need to find H plus. We can use this formula. Okay, so 1 times 10 to the power negative 14 times H plus, which is the question, unknown, and times 4.66 times 10 to the power negative 2. You get H plus, which is 2.15 times 10 to the power negative 13, and pH will be negative log 2.15 times 10 to the power negative 13, which is 12.668. Calcium hydroxide reacts with carbon dioxide to reform calcium carbonate. Determine the mass in gram of CaCO3 solid produced by reacting 2.41 decimeter cube of 2.33 times 10 to the power negative 2 mole decimeter cube of CaOH2 with 0.75 decimeter cube of CO2 at STP. So volume and concentration of NaOH is known, and volume of CO2 is also known. Therefore, we need to find out which one is the limiting reactant. So let me just copy it down back the reaction. Okay, so for mole of CaOH2, the volume is known, concentration is known, so that would be 2.33 times 10 to the power negative 2 times 2.41. You will get 0.0562. Okay, so 0.0562 mole. And for CO2, N V divided by Vm. So we've got V, which is 0.75 divided by 22.7. You get 0.033. So here would be 0.033. So this one will be the limiting reactant. Therefore, the mole of CaCO3 will be plus 0.033. Okay, so because we know now the mole of CaCO3, so we can calculate mass of CaCO3, because as this is the question, N times Mr. So N will be 0.033 times Mr of CaCO3, which is 100.09. Then you get 3.30 gram. .85 gram of CaCO3 was collected in the experiment in D1. Calculate the percentage yield. Percentage yield would be actual yield divided by theoretical yield, which is 2.85 gram, and the theoretical yield just now is 3.33 gram, the previous question, times 100, which is 86.4%. Outline how one calcium compound in the lime cycle can reduce a problem caused by acid deposition. You can do or add calcium hydroxide to acid water or maybe river, because when you add calcium hydroxide to acidic bodies of water, it will neutralize the acidity. The properties of elements can be predicted from their position in the periodic table. Explain why Si, silicon, has a smaller atomic radius than aluminum. Si, number 14, the proton number or atomic number is 14, and electron number also 14. Al is 13. So why silicon has a smaller atomic radius than aluminum? Because silicon has bigger nuclear charge than aluminum, as it has more proton number, causing stronger attraction to pull on the outer electrons, as aluminum is in the same period with silicon. It will have the same number of electron shell, and thus will have the same amount of shielding. Explain why the first ionization of sulfur is lower than of phosphorus. Sulfur, it's 16, number of electron is 1s. I will just make it short notation. So 3s2, 3p4, and for phosphorus, 3s2, 3p3. If you see on the orbital, that would be pair, and this one, that would be unpair. Okay, so because it is paired for sulfur, it will have greater electron repulsion due to the pair electron in sulfur. So it is easier to remove an outer electron. State the condensed electron configurations for Cr and Cr3+. Cr has number of proton, electron, 24. So this becomes 21 because 3 plus lose 3 electron. So for the short notation, that would be for S1 3d5, and this one, that would be 3d3, because we need to take 1 from here and then 2 from here, because the electron now reduce because it has the charge 3 plus. Describe metallic bonding and how it contributes to electrical conductivity, because it has electrostatic attraction between cations and C of delocalized electron, the electrons can move in the lattice and are capable of conducting charge. Deduce giving a reason which complex ion CrCN6 3- or CrOH6 3- absorbs higher energy light. Use section 15. As you can see, 15 on the spectrochemical series, section 15, Cn is stronger compared to OH. Therefore, which one that will absorb higher energy light? The answer is CrCN6 3- because it will absorb higher energy light, because Cn- is higher up on the spectrochemical series than OH. This means that Cn causes greater d orbital splitting, increases the energy difference between d orbital, greater splitting, so higher energy light will be absorbed. CrOH6 3- forms a green solution. Estimate a wavelength of light absorbed by this complex. Any value between 647 and 700 nanometer. So CrOH6 3- forms green solution. If we see on the color wheel, so it appears as a green solution. It means it absorbs red color between 647 to 700 nanometer. So when a solution appears in color, it because the solution absorbs certain of wavelength of visible light. The solution appears in green color, yeah? So it means that the solution absorbs the color of light that complementary to green. It is located across from each other on the color wheel. So it is absorbing red light, appears as a green solution. Deduce the Lewis electron dot structure and molecular geometry of sulfur tetrafluoride and sulfur dichloride SCl2. So SF4 comes from group 6, so it should be 6, and molecular geometry is seesaw, and for SCl that would be bend or V shape. Suggest giving a reason the relative volatilities of Cl2 and H2O. H2O is less volatile because it has hydrogen bond compare to SCl2 as H2O forms hydrogen bonding, while SCl2 doesn't. SCl2 has dipole force because it has a lone pair, so it's polar, which is weaker than hydrogen bond. Thus, their bond is easily to break. Oxidation and reduction reaction can have a variety of commercial use. A student decides to build a voltaic cell consisting of aluminum electrode and a tin electrode and solution of aluminum nitrate and tin nitrate. Electron flow is represented on the diagram. Okay, for a voltaic cell, electron flows from anode to cathode. Okay, so we've got Al and Sn. Al is more reactive, therefore it experiences oxidation. So this would be Al, and the solution will be AlNO3, and this one of course will be Sn, and this one will be SnNO3, 2, and this one will be volt, which is voltmeter, and this one is salt bridge. Write the equation for the expected overall chemical reaction in A. Okay, so anode, you got Al, and here we've got Sn2 plus, because this belong to Sn, Al3 plus. Okay, anode experience oxidation, losing electron. Cathode experience reduction, gaining electron. Okay, so now let's do for anode. Anode losing electron for Al. So Al solid will be Al3 plus aqueous plus electron, 3 electron. Okay, and for cathode would be Sn2 plus 2 electron, aqueous because it gains electron, so that would be Sn solid. Okay, the electrons are not balanced, so we can do times 2 times 3. Let's repeat it again. So that would be 2 Als produce 2 Al3 plus aqueous and 6 electron. And for this one, 3 Sn2 plus aqueous produce plus 6 electron produce 3 Sn solid. This one finish, and you add them, so that would be 2 Al solid plus 3 Sn2 plus aqueous, 2 Al3 plus 3 plus aqueous, and 3 Sn solid. Calculate the cell potential using section 24 of the data booklet. So E cell would be reduction minus oxidation. Reduction, as we know, is Sn. So 24. So let's see, Sn would be negative 0.14, and for Al would be negative 166. Okay, so that would be negative 0.14 minus 1.66. You get plus 1.52 volt. Calculate the Gibbs free energy change delta G in kilojoule for the cell using section 1 of the data booklet. So delta G will be NF, negative NFE, and we've got 6 electron here involved, 6, not 3 or 2, but 6 electron. So that would be negative 6 times Faraday, which is 9.65 times 10 to the power 4 times 1.52 from the previous question. You get negative 88080 joule per mole, which is negative 880 kilojoule per mole. Organic chemistry can be used to synthesize a variety of products. Several products can be synthesized from butene. Draw the structure of the final product for each of the following chemical reaction. So if you add H2O, that would be OH and H, and this one will be H and H. So CH3 and CH, OH, CH, and now H, CH3. It will be the same if you put OH here because butanol is symmetrical. And for this one, H, CH, CH again, CH, H. Okay? Determine the change in enthalpy delta H for the combustion of butene using section 11, which is average bond enthalpy. So it's always good for you to draw the structure so it will be clear the bonds that are involved. C, H, C, H, H, and H plus 6O2. This one 4 C double bond O. So we got O here and then 4 OH and then H. So that would be 8CH plus 2C, C and then C plus C double bond C plus 6O double bond O. This is 2 times 4, 8 C double bond O times OH2, so 8 OH. 8 times 414 plus 2, 346 plus 614 plus 6, 498 will be 8 times 804 times plus 8 times 463. That would be 7,606, 10,136. So delta H would be 7,606 minus 10,136, which is negative 2,530 joule. State the hybridization of the carbon 1 and 2 atoms in butene. So the structure would be CH3 here, CH, CH, CH3. Okay, for the first one, this one, it has 4 domain. If it has 4 domain, it will be sp3. And for the second one, it has 3 domain. That would be sp2. 2 domain like this. Okay. This 2 domain, that would be sp. Draw a diagram to show how sigma and pi bonds are formed between atoms. Could be like this. Okay. And for this one, it will be like this. Or it could be like this. Okay. So head-on overlap or sideway overlap. Sketch the mechanism for the reaction 2-methylbutene with hydrogen bromide using curly arrows. Okay, so H3CH3, CCH3, double bond CH and CH3 when it reacts with HBr, this will go here, and this should be like this. Okay, let me just fix it. HBr, and it will form a carbocation, CH3, CH and C and CH3. So Br ion will go here, and it will produce addition product. So the pi bond between this 2C in 2-methyl-butene acts as a nucleophile, donating the 2p pi electron to an electrophile, this H. HBr, where H atom is an electrophilic center, has a polar bond. So the pair of electrons from the carbon double bond are used, forming a new bond with H and Br minus. The pi bond now is no longer exists, right? Because it's forming a carbocation intermediate, and Br minus quickly react with the carbocation intermediate as a nucleophile, producing addition product. Explain why the major organic product is 2-bromo-2-methylbutane and not 2-bromo-3-methylbutane. 2-bromo-methylbutane, that would be CH3, CH3, Br, CH2, CH2. So this is 2-methylbutane. But for 2-bromo-3-methylbutane, that would be CH3, CBr, CH3, CH, CH, CH3. Okay, so these are this C, that Br that is connected to this C has 3 alkyl, so it's a tertiary carbocation. It will form tertiary carbocation because attached to 3 alkyl. But for this one, only attached to 2 alkyl. So this one is secondary carbocation. Okay, tertiary carbocation is more stable than secondary carbocation. Okay. Combustion analysis of unknown organic compound indicated that it contained only carbon, hydrogen, and oxygen. Deduce 2 features of this molecule that can be obtained from the mass spectrum. Use section 28 of the data booklet. Okay, when it's 58, I always said when there is biggest number on the spectrum, so that would be the actual compound. Okay, so the molar mass of a molecule is 58. Molecular mass of the molecule is 58 gram per mole. And what happened if it's 43? So 58 minus 43 is 15. 15 means CH3. So this 43, the number, means loose methyl fragment. Okay, CH3, because it's 15. So 58 minus 15 is 43. Identify the bond responsible for the absorption at A in the infrared spectrum. Use section 28. This one is 1700 to 1750, which is C carbonyl. So C double bond O. Deduce the identity of the unknown compound using the previous information. Only one signal. It means that 58 molecular mass is a symmetrical carbonyl molecule, which is propanone. So information deduced from HNMR, because it has only one hydrogen or one proton. Environment, it means it's symmetrical. So the compound would be propanone. Because why? It has C double bond O. It's symmetrical. And the molecular mass is also 58. Let's draw propanone. So this would be C3860, which is 58, and it's symmetrical. So this one just now 43, and this one is 15. Draw the stereoisomers of butane 2-ol using wedge dash type representation. So COH, and that would be C2H5, and this would be CH3, and this would be H, and COH, this would be CH3, this would be H, and this would be okay, so it's a bit long then, yeah. Okay, try to make it the same here. Okay, let me try. So that would be like this. So this C2H5. Outline how two enantiomers can be distinguished using a polarimeter. Because of the rotation of enantiomer of plane, polarize light, and equal degrees or angle showing opposite direction or rotation based on this. Okay, ethanol is used as a fuel. Write the chemical equation for the complete combustion of ethanol. CH3CH2OH liquid produce reacts with gas, produce CO2 because it's complete, gas, and H2O. So this would be 3, this would be 2, and then this would be 3. Then balance. Deduce the change enthalpy delta H in kilojoule when 56 grams of ethanol is burned. Use section 13. Okay, first, because the mass is known, so we can calculate mole, which is 56 divided by 46.08. Then you get 1.215 mole. And delta H of combustion based on the section 13 for the ethanol, if you've checked the data booklet, you will get negative 1,367 kilojoule per mole. So delta H would be 1.215 mole times negative 1,367 kilojoule per mole. Then you will get negative 1,661 kilojoule. It should be negative because it's combustion, increase in temperature. That's why it's negative. Oxidation of ethanol. Ethanol is primary alcohol. with potassium dichromate can form two different organic products. So primary alcohol, when you oxidize the first one with distillation and potassium dichromate, of course, you will produce aldehyde. So in case of ethanol, it will produce ethanol, and you oxidize again, this time distillation and reflux, you will get carboxylic acid, which is ethanoic acid. Okay, so for ethanol to ethanol, you need distillation and potassium dichromate, and from aldehyde to carboxylic acid, which is ethanoic acid, you need potassium dichromate and both distillation and reflux. Write the equation and name the organic product when ethanol react with carboxylic acid, it will produce esters and water. For esters, the name is alkyl alkanoate. Okay, so equation would be CH3 CH2OH, because it's ethanol, plus methanoic acid HCOOH will produce HCOOCH2 CH3 plus water. The name will be ethyl methanoate. Let me break it down here. So CHHHOH plus HCOOH. So this O will bond with this C. This will be discard. Produce water. So this will be HC double bond O, and then O, okay, and then CH2 and CH3. So HCOOCH2 CH3. The name, this one will be ethyl, and this, because it's 1 methanoate. Okay, this one methanoate. Sketch the titration curve of the methanoic acid with sodium hydroxide, showing how you would determine methanoic acid pKa. Okay, pKa is an half of the equivalence point. This would be the equivalence point, so around this one, and because strong base, so that would be here. Okay, let's say maybe around here. And methanoic acid is a weak acid, so now the half here, this will be equivalent point. Okay, so let me just do it like this. Okay, so we start around maybe 4. Okay, so this one maybe 4, and half of the, so pKa will be half of this, so I will do like this. Yeah, okay. All right, so it should have increasing S shape, and pH will be bigger than 7, because between weak acid and strong base. Identify an indicator that could be used for the titration 5D1, because the pH equivalent is bigger than 7. So from the section 22, section 22. Okay, you can choose either phenol red or PP, phenolphthalein. So the answer will be phenolphthalein. Or if you answer also phenol red, will be also correct. Determine the concentration of methanoic acid in a solution of pH 4.12. Use section 21 of the data booklet. So for methanoic acid, when it is dissolved in water, will produce HCOO minus and H plus. So to calculate pH, you can do pKa plus log HCOO minus divided by HCOOH. We're looking for HCOOH, concentration of HCOOH. So pH is 4.12. pKa, if you see section 21 data booklet, would be 3.75 plus logarithm is 10 to the power 4.12. Okay, because the pH 4.12 divided by HCOOH. Okay, so 10 to the power H plus here. Therefore, concentration of HCOOH after you do the calculation would be 3.24 times 10 to the power -5 mole per decimeter cube. Identify if aqueous solutions of the following salts are acidic, basic, or neutral. Sodium methanoate, HCOO and A. When it dissociates, will produce HCOO negative plus and A plus. Okay, and this HCOO minus will be hydrolyzed slightly in water, and when it reacts with water, it will produce HCO2H and OH minus. Therefore, it's basic. Ammonium chloride, it will dissociate to B and F4 plus and H4 plus and Cl minus. And this one also, when it reacts with water, it will produce an H3 and H3O plus. This one make it, the solution becomes acidic. But for sodium nitrate, neither ion hydrolyzes appreciably in water, so this would be neutral. Okay, these are the data. Bromate and bromide ions react with acidic solution, aqueous solution. Determine the rate expression for the reaction. So we need to find the order of reaction. For BrO3 minus, we see these are the same. So this concentration and this is the rate of reaction. As you can see, double the concentration, double the rate of reaction. So this one will be first order. And for Br minus, we use this one. These are the same, so would be this one. Double the concentration, double the rate of reaction. Okay, initial rate, I mean, that would be also first order. And for this one, these are the same, so 1 and 4. Double the concentration, 3.2 or 32 divided by 8, which is 4, so it's quadruple. Therefore, second order. If the concentration stay the same, that would be 0 order. Double the concentration, the initial rate stay the same, that would be 0 order. Therefore, the rate of expression would be K BrO3 minus Br minus H plus to the power 2. Determine the value and unit of the rate constant using the rate expression in A. So K is rate divided by concentration of BrO3 minus Br minus H plus squared. I'm using the first one, this data. You just need to plot into the equation. So that would be 8 times 10 to the power negative 4 mole decimeter to the power negative 3 s to the power negative 1. So that would be 0.1 mole decimeter to the power negative 3, 0.1 mole decimeter to the power negative 3, 0.1 mole decimeter to the power negative 3, but squared. So this finish here. Okay, so that would be 8 times 10 to the power negative 4, and this would be, this is double, so 10 to the power negative 4 mole decimeter to the power negative 3. This would be squared, mole squared, and this decimeter negative 6. Then it will be 8 times this one stay the same, and mole, there are 3, so mole to the power negative 3 decimeter to the power 9, and s to the power negative 1. Consider the following equilibrium reaction. State the equilibrium constant. Kc would be SO3 to the power 2, SO2 to the power 2, O2 to the power 1. State and explain how the equilibrium would be affected by increasing the volume of the reaction container at a constant temperature. So P is directly inversely proportional to 1 over V. Okay, inversely proportional to volume. So pressure decreases as volume increases. The reaction shift to site with more moles of gas when the pressure decrease. So the one that has more mole of gas is left side or reactant, because here is 3 and here is 2. Therefore, reaction shifts left. Okay, SO2, O2, and SO3 are mixed and allowed to reach equilibrium at 600 degrees Celsius. The mole of initial, or the initial concentration are these, and equilibrium concentration are these. So we need to find out how many or the concentration, reacted concentration. So that would be, let me just write down here, 2SO2 plus O2 produce 2SO3. Initial, it's 2, 1.5, and 3. Reacted and equilibrium. At equilibrium, this would be 1.5. 1.5. Okay. So how many mole that is reacted? 0.5. And for this one, because the coefficient is 1, so 1 over 2 times 0.5, which is 2.5. So you've got 1.25. And for this one, because the coefficients are the same, so plus 0.5. Always on the product will be plus, on the reactant will be minus. So 3.5. Therefore, concentration of oxygen, it's 1.25 mole per decimeter cube, and SO3 would be 3.5 mole per decimeter cube. So Kc would be 3.5 squared divided by 1.5 squared times 1.25. You will get 4.36. That's all for the explanation for the Chemistry Higher Level Paper 2, May 2021, Time Zone 2. If you find this video is helpful for your exam preparation and revision, please don't forget to subscribe and let your other friend knows about my channel to support me. Thank you for watching, and bye.